In this video, we're going to be looking at transverse waves. Transverse waves occur all around us in nature, such as the waves in the ocean. Transverse waves consist of a crest and a trough. The crest being the highest point of a transverse wave, and the trough being the lowest. To imagine this, think of being at a beach, and a wave comes towards you and you suddenly get lifted really high off the sand. And then the wave passes and you can suddenly go to the sand and the water is suddenly quite low. All transverse waves have a wavelength. This is the distance between the beginning of a crest and the end of the trough. This changes constantly through transverse waves and has a very serious effect on the amount of energy the wave transfers. The amplitude is how high or low the wave goes, with the amplitude always being the same, both up and down. In a transverse wave, the particles oscillate up and down, as annotated by that arrow there. This means that as the waves pass through, the particle will raise up and then go back down, but not actually move back and forward. Transverse waves propagate away from their source, such as in the ocean or in a puddle. It'll spread out in all directions from the source. Transverse waves are graphed to look like this, much like a sine wave, for those who know what that is. It's represented as displacement over time, meaning as time changes, so will the displacement. One place you'll see transverse waves is on a cathode ray oscilloscope, which allow us to see sound. It converts the longitudinal wave of sound into a transverse wave that we can easily look at and analyze. A very important example of a transverse wave is electromagnetic radiation, but we'll go through that in a later video. As always, there's more study notes below this video. Thanks for watching. Some other important parts of a transverse wave is the frequency, or the number of waves to pass a given point in a second, measured in hertz, the velocity, or the speed at which the wave transfers energy away from the source, and the period, which is the time it takes for a wave to complete one whole crest and one whole trough. A very important formula you need to know is that velocity equals frequency times wavelength, here shown as v equals f lambda. Basically what this means is that the speed of the wave is equal to the frequency of the wave times its wavelength. Now this is one of the most important formulas in terms of waves and is often used in questions. You have to be able to know to rearrange it so that frequency equals velocity over lambda and that wavelength equals velocity over frequency. As always, there's more study notes below this video. Thanks for watching.